This session is on exception handling. Exception is an abnormal condition that disrupts the normal flow of program. In a regular scenario, if you run any program, it works how we expected it to be working. So there may not be any errors, it may execute all it works in a positive manner, it produces a result that we expected. But in some cases, we may not be always having the expected results. There may be some abnormal condition that disrupts the flow of program. So it may not be executing in a normal way. You may get some errors in some scenarios. So those are called as the exceptions. Let's take an example where the passengers are going to travel in a flight. In a normal scenario, the flight reaches the destination as per the schedule. But there can be some exceptions. So there could be some flights, the parts are not working in the flights, or there could be weather problems, there could be delays in arrivals. So these things are kind of abnormal situations. It's not in a normal situation. The flight, gets to the airport on time, and it reaches the destination on time. There is no weather problems. There is no flight problems. I mean parts problems. It's all going to work seamlessly fine in a normal situation. But there could be some day where there's a weather problem, and the the flight cannot reach as per schedule. But still, that is okay. We know that these problems can happen, and we have solutions for this problem. We have an alternative route for this problem. We can anticipate these situations can happen, and we can have some logic to handle this problem or some solutions for this problem. What if the weather is not good? How to deal with that? I have a course of action for that. There are some situations which is errors which we don't have any course of actions because we never anticipated that this problem could happen. Like emergency situations where you have to close the airport, there is a flood which you never expected, and that the flights are going to be cancelled for a week or whatever it is. So there could be some emergency situations which demands, which is not something we anticipated to happen, or even if it happens, there is no course of corrections there actually. So exceptions are situations that can be handled and proceeded with alternative path, or at least it can be gracefully reported. Whereas emergency situation like errors is like situations that is not anticipated and it cannot be handled. It doesn't make sense to handle or think about a alternative path to proceed forward because it's a kind of it's kind of a overall stopping situations where we cannot proceed further. So here is a program where you have a main method which is calling a process method, and in the process method it tries to get a input from the user, and it tries to divide 10 by that input whatever the user has given, and it just prints the number, the result of the division, and then it says process complete. Then it handles back to the main method, and the main method is printing the main complete. So this is how the results would be in a normal flow. The user enters the number as 5. It's dividing 10 by 5, which is giving the result as 2. It's printing process complete. It's printing main complete. So everything goes as per in a normal flow. Everything works fine. There's no problem. There's no errors. Okay. Now, if the user gives instead of 5, if he gives 0, the same program which worked before now is going to start failing. You get an exception. What is the exception is? Exception in thread main java.lang.arithmetic exception slash by 0, divide by 0. Basically, it tries to divide integer k is equal to 10 by 0. There it got the problem. 10 by 0 is going to be an infinity, so Java cannot handle that. So it says, it's a divide by 0. I'm going to throw an exception, and it throws an exception out there. It is also listing out which line it has thrown, like it is happening in the process method which is in demo1.java, and it is also specifying the line numbers there where it happened actually. So this is called the stack trace, where which is helping the developers to understand where it went wrong, what is the exception it has produced, and where it went wrong, what line number it went wrong, and what method it went wrong, and this method is called by which method and in which line number. You see here we have the demo one process method, we have the process method is called by main method, so that is also indicated here. So it is in Java 8, line number is if you come from the bottom to top, it happened in the main method, which is in Java, I mean demo1.java line number 8, and which is calling the process method, and in process method it happened in line number 16. And what happened is divide by zero error, which is an arithmetic exception. So it gives you the clear stack trace of what happened here to the user. So we should have anticipated this problem, and you should have written a code, should have a way to handle when things goes wrong. That is what exception handling is going to provide us. So we have to think about the situations where it can go wrong, and we should have either have an alternative way to deal with that situation, or at least report it gracefully. When I say report it gracefully, we should not throw these errors like exception in thread main and to the users in the screen when you're accessing web UI. The users may not have any technical knowledge, and they don't even need to see what program you have written for making their things happen. So you should have reported in a graceful way, saying that if there is some exceptions, you should have said like, hey, there is some delay, or there is some outage in the system, please try again sometime, or so there is some error happened, we reported to the technical team, like that. So it should be having a proper way of communications to the users when you are dealing with these exceptions. So either at least you recover that error if possible. If you are not possible, at least gracefully handle that situation. So that's where exception handling is going to help you with. So we have 5 keywords which is going to be providing you the exception handling in Java. It is try, catch, finally, throws, and throw. These are the 5 keywords which is going to help you with handling the exceptions in Java. So try specifies a block where the code that may produce an exception is placed. So whichever code is producing, if whichever you think this code may produce an exception, you will be putting that under the try block. Catch is the handles the exception here. So here, if you have a try block, you will obviously having a catch block. Actually, it's not mandatory again, but you will mostly having a catch block. So which means the try block is the one within the try block, any line can produce an exception, and catch block will say like, if at all the exception has been produced, how to handle that. So you'll be having the handlers. Catch is nothing but handlers. For each type of exception, you can provide one handler for it. Each type of exception that you can anticipate in that try block, you can provide a handler for that in the catch block, which means that you can have more than one handlers. You can have more than one catch block here. So each catch block will be handling different types of exceptions here. Finally block will be executed always. Whether there is an exception occurred or not, it is going to execute all the time. So this is basically used to any cleanup activities. Suppose if you have opened up a object, if you opened up a file, or if you opened up a database which is going to store a large amount of file information into the heap memory, and once you loaded the file, the next line it got an exception. So this file, whatever you have opened, this object is still going to be sitting in the memory for a long time, but it has never been cleaned up, so that Java thinks that this memory is getting used by some other object, but you have never cleaned that memory up actually. Because you encountered an exception, so you are not able to clean it up. You abnormally terminated the program and you came out actually. So those type of situations is finally is going to help you. So you will be closing the resource in the finally block, which means whether you got the exception or not, it is going to always execute, which means it is going to always close that resources, always clean up that resources. That's where the finally block is going to help you here. Next is the throws block. Throws. Throws indicates that exception may occur in a method. It is just a way of saying to the user that this particular method can throw an exception. this particular method is capable of throwing an exception. So it's always specified in the method signature. We'll see this in detail while we look at the code samples. The next is a throw. It is used to throw an exception. Suppose if you wanted to throw an exception, you can use the throw keyword to throw an exception. Mostly it will be the user who is going to throw the exception, and he'll be throwing a user defined exception by using the throw class. Throw class, I mean CLAUSE. So try block should be always followed by a catch block or finally block or both. But it should have either catch or finally to be followed by try. You cannot just have try alone. Okay. So let's see the flow of some programs, how this works when there is an exception happening. So we have we have the main function, main method, which is calling the process, and it's having a system.out main completed once the process is successful. You see there is a private static void process method. I'm printing process line 1 once you enter the process method, and then it is getting divided by 0. So which means this is definitely going to produce an exception. And then after the exception line, I'm printing process line 2 and process line 3. So here, the 10 by 0 is going to produce an arithmetic exception, which is a divide by 0 exception will be thrown at this point. So what happens is, the moment you get an exception, anything below that lines, any lines below that, the line which caused the exception will not be executed. So here process line 2, process line 3 will not be executed. Okay, and then now process is being called by main method, so it goes back there and it is also not going to get executed. It's going to throw back to the calling method. So who is calling main is the JVM. So it's going to say JVM that there is an exception, and JVM just prints the stack trace like this. So what executed? Just the process line 1 get executed, and you got an error in the next line. So anything below that did not get executed because it's an abnormal termination. We didn't expect the error there. If there is no error, it would have executed process line 2 and 3 and main completed, but it did not. So we got an exception and we throw it back to the main method. Main method is also throwing back to the JVM, and it did not execute the main completed in this case. Okay. Now let's put in the previous slide, we don't had any try catch and all. We just had put there and we got an exception. Now let's try to add a try catch block here. So as you have seen here, the same code, but I have put a try before the first line of the statement in process method, and I suspected that these 4 lines may produce some exception. So I put those lines into the try block, which I suspect that can produce an exception. And what type of exception it would produce? I suspect it would produce an arithmetic exception. So I have a handler for that. So the handler says catch arithmetic exception. So here what is going to happen is, when it executes k is equal to 10 by 0, it is going to produce an arithmetic exception. As you know, when it produces an exception, it is not going to execute the remaining lines of the program, which means here it is not going to execute the remaining lines of the try block. It's just not going to execute the remaining lines of the try block because it is within the try block. So within that block is not going to execute any lines, and it is going to look out for any handler. So since the exception, hey, I got an arithmetic exception, do I have any handler for handling it? Then there is a catch block here which says that, hey, I'm here to handle your exception. So it is going to get executed because it matches the exception what got produced. So here what is going to happen is, it's going to handle the exception by printing arithmetic exception line 1. Once it prints that line, that means the exception occurred and I was able to handle that exception and I am able to move forward. So now what happens is, the process line 4 and 5 will get executed. So process line 1 will be executed, and arithmetic exception line 1 will be executed. Line 4, line 5 will be executed. Line 2 and line 3 will not be executed because when you hit an exception, the remaining lines in the try block will not be executed. So you get the output as line 1, arithmetic exception line 1, line 4, line 5, and it has completed successfully. This process method has completed successfully. It executed till the last line of the program. It returns back to the process main method and it prints the main completed. Let's take another flow example. So here again the same thing, but as you see here, I have string s equal to null and s dot to lowercase. So here what happens is I'm trying to make null dot to lowercase. Anything, if you invoke any method on a null object, you are going to get a null pointer exception. So in this case, what happens is I have two handlers. I expect a arithmetic exception as well as a null pointer exception can happen in this block. Of course, arithmetic exception will not happen, but I have just had the handler here. So what happens here is this block is now going to throw a null pointer exception. So I have two handlers for this. One is arithmetic exception handler, null pointer exception handler, two catch blocks for this. Now, which is going to match here? Arithmetic exception will not match. Only null pointer exception handler is going to match. And you are going to print only NP exception line 1. Again, in this case, line 2 and line 3 will not be executed. Arithmetic exception line 1 will not be executed because it is not matching that exception. Only the NP exception line 1 will be executed, followed by line 4, line 5 and main completed. Again, the exception has been handled gracefully, so it proceeded with the remaining lines of the process method and also the main method. Okay, next thing is we have like a main method which is going to call the process, and here we have integer k is equals integer dot parseInt of abc. So what is the parseInt method is going to do is it's going to convert a string argument into an integer argument, provided you provide the integer values as a string. Here we are providing a string value. You cannot convert abc into an integer. You can convert 1, 2, 3 into an integer, but not abc into an integer. So here ABC is a string, I cannot convert it into integer, so I get an exception called number format exception when you attempt to do like this. So here again, process line 2 and 3 will not be executed because you got an exception. The remaining parts in the try block will not be executed. The catch here is having only arithmetic exception, but I produce number format exception. Do I have any catch block for number format exception in this scenario? I don't have it, which means it looks for any catch there. There is no catch, which means it is not going to execute anything remaining there. Actually, it's not going to execute this part because it is not matching with that exception, and it will not of course execute process line 4 and 5 because the exception is not handled gracefully so that it can execute the remaining lines. So it's abnormally going to go back to the process method actually. So it's not going to execute any lines here. It's just going to hit that exception. There is no handler. It's not going to execute any remaining lines, both in the try block as well as in the entire process method, and then it is going back to the main method. It checks whether the main method is having any handler. Main method does not have any catch block or any handler there, so it is going to not execute the main completed also, and it is going to go and throw back to the JVM, and JVM is going to produce a exception stack trace. So this is what is going to happen. Process line 1 will be printed. Apart from that, nothing will be printed because even though there is a try catch block, the catch block is not matching the exception that it is throwing, so it is not going to execute anything. It's going to go back to the calling program, and main is also not having any catch handler, so it's going to call back to the JVM, which is going to print the exception stack trace where it happened. Okay, another scenario here, as you see here, this is for the finally example. I have a try block which is not actually giving any exceptions here. It's just printing 3 lines, but I have an exception handler for arithmetic exception, which means it's not going to get executed. So here it is going to, but we have a finally block which says finally line 1. So here finally, as I said, whether you have the exception or not, it is going to get executed. So in this scenario, exception line 1 will not be get executing, and the other things will be executed. So you have process line 1, 2, 3. Finally, line 1 will be executed. Line 4, line 5 will be executed. Main complete will be executed. So it's a positive flow. where you don't have any exceptions occurred, still finally block will get executed. We'll talk about a negative flow here. I just added one line k is equal to 10 by 0 in this. So which means it is going to throw an arithmetic exception, and there is a handler for arithmetic exception, which means process line 2, line 3 will not be executed. Arithmetic exception line 1 will be executed. But you observe that even though it is even though it is executing the catch block, still the finally block will be executed. So whether you execute the catch block or not, finally block will be there to get executed all the time. Okay, next scenario, we are throwing a number format exception, which is integer.parseInt of abc, but we don't have a handler for it, right? So in this case, in the last example, what we saw is it just prints process line 1, and it did not execute line 2, line 3. It did arithmetic exception is not matching, so it's not going to execute. It's not going to execute any lines in this process method. It goes to see a main method is having any handler for number format exception. Main method is also not having handler, so it is going to go back to the JVM. So in this case, what's going to happen is it's going to follow the same path, but we have a finally there actually. So as I said whether you hit the exception or not, finally block will be definitely executed, right? So in this case, it's going to create number format exception. Line 2, line 3 will not be executed. Arithmetic exception will not be executed, but finally will be executed. And it is not going to execute line 4 and line 5 because the exception is not handled here. So it is not going to execute any lines in the process method. If it is handled, it is going to execute line 4 and line 5, but it's not handling. You have a handler, but it is not handling that. It's not a proper handler for that exception. So it's going to throw back this one to the calling method. And the calling method is also not having any handler for number format exception. So it is going to go back to the JVM. So you're going to get the stack trace here. So main completed will not be executed. As you see, there is a line 1 gets printed, and also finally line 1 will be printed. So finally will be definitely executed, no matter whether you hit an exception or not actually. So there are two situations where the finally block will not be executed. They are if you get an error, like when you are executing some statement, you got an out of memory error. Okay, that means you cannot proceed forward to the next line itself. So in that scenario, finally cannot execute because you are out at that time. You don't have any memory to execute any instructions. So finally will not be executed. There is another case when you abnormally terminate you specifically say I want to exit it now by using the statement like system.exit of 0 or exit of any status. When you do that, that time you are going to exit at that point of time. There will not be any finally executed even in that scenarios. So there are two scenarios when finally will not be executed. One, if you hit any error, not an exception. If you hit any error, and if the user has written a statement like system.exit of any status, those two times finally will not be executed. Coming to the exception hierarchy, so it starts with the object. So throwable is the class which extends from object, and error extends from throwable, and exception extends from throwable. So error and exception basically extends from the throwable class, and runtime exception is extending from the exception class. And there are a few more exception classes, like there are a lot of exception classes which is extending from the exception class, which is some examples are IO exception, SQL exception, parse exception. All these things are extending from the exception class directly. And we have runtime exception class, which is extended by null pointer exception, arithmetic exception, number format exception. All the exceptions which we see in the previous slides are all extending from runtime exception, and runtime exception is extending from the exception class. So these are all the exception area, and we have some errors as well. We have stack overflow error, which is extending from error class, out of memory error. These are all going to be extending from the error class. So we see the ones in the orange, they are all checked exceptions. We'll talk about what is checked exceptions. And the ones you see in the orange color, like throwable exception, IO exception, SQL exception, parse exception. Anything that is not runtime exception or error is going to be checked exception. Anything that is not runtime exception or error is going to be checked exception. If it is if it is error or runtime exception, then it is going to be unchecked exception. You can also call it as a runtime exception. Okay. So here, runtime exception, you don't need to handle it. So last time we had like null pointer exception, arithmetic exception. It's not mandatory that you have to put try catch and you have to handle that exception. If you handle it, that's fine. It's good for you, but it's not mandatory that you have to put a try block and catch block and handle that. Whereas in checked exception, if you are going to get any IO exception or file not found exception or SQL exception, you have to handle it or throw up the cal stack. Either you have to say, either you have to put a try catch block and handle that exception, or you have to at least say that, hey, I'm going to throw it to my caller of this method. Actually, you have to specify explicitly that I'm going to throw this method can produce an exception. If at all it produces an exception, I'm not handling it, I'm throwing it to my caller. So you explicitly declare that. So for the checked exceptions, for the unchecked exceptions, you don't need to do that. Actually, you don't need to throw it or you don't need to handle it. It's not mandatory to do that. If you do it, that's well and good, nobody is going to bother about it. But if you don't do it, it's not going to complain for it. But in checked exception, you have to mandatorily handle it or throw it. Okay. So this is the catch sequence we want to discuss. So when you can have more than one catch for a try block, right? Which I said. So let's take this example: k is equal to 10 by d, and then system.println k. If you pass 0, it's going to get into arithmetic exception. If you pass 5, there is no exceptions. Will be handler will be invoked. It's a normal flow, but you have two handler for it: arithmetic exception and exception block here. So always you put your subclasses before your parent classes, right? So always subclass exception should be handled first, followed by the parent class. You cannot put catch exception and followed by arithmetic exception, because what happens is when there is a hit, when it is hitting an arithmetic exception, it will not come below and check. The first is exception. So arithmetic exception is a part of exception. So it is going to always execute the exception code, exception catch handler, and not the arithmetic exception catch handler. So in fact, you are going to get a compilation error saying that this arithmetic exception code is not reachable for me, because it is all, whatever you are going to write in this arithmetic exception will not be invoked at all. Anytime you hit an exception code will be coming first, so it is going to handle it. So it says unreachable catch block for arithmetic exception. It is already handled by the catch block for exception. So when you are writing the catch number of handlers, you have to be careful there. You have to be always writing the subclasses before the parent class. And coming last to the custom exception, so you can create your own exceptions in Java. Like we had a lot of exceptions like IO exception, SQL exception. All these things are created by Java for you, but you can also create your own exceptions. So all that you need to do is extend the exception classes. So you can extend either any of the exception class. You can extend exception. You can extend IO exception. You can extend parse exception. You can extend any exception classes. If you extend the runtime exception classes, either the runtime exception or null pointer exception, anything that comes under the runtime exception classes, your exception class will become an unchecked class. If you extend from any checked exception classes, then your exception will become a checked exception. Okay, so let's see an example here. We have defined the invalid amount exception extends the runtime exception here. So when I say extends runtime exception, now my exception class is an unchecked exception class. That means the user need not handle it. If he's handling it, that's well and good, but he doesn't need to handle it. I'm not forcing the user to handle it. So here we have extending from the runtime exception, and it receives a double argument. I'm having a constructor to receive a double argument, and I'm calling the super class, which is a runtime exception constructor, because runtime exception constructor is only going to accept a string argument. So I'm just getting the double argument and I'm just appending that with the invalid amount colon and then passing that as a string to the superclass constructor. All that my exception class is doing is that. Now in my I have a bank account class. So when the user deposits an amount, let's say he's giving a negative value for the deposit. So in that scenario, I can say instead of doing a system.out.println, I will say like, if amount is less than or equal to 0 when you try to deposit, I'm going to throw new invalid amount exception and I'm going to put that amount there. So this, whenever user tries to attempt to do this, he's going to get this exception. So this is an exception that is not available in Java, but you are creating it in a customized way. So if a class extends runtime exception or its subclasses, they become unchecked exception. Otherwise, they are considered to be a checked exceptions. Okay. So let's move on to the Eclipse so that we can do some exercise on this exception classes. Okay. Let's create a package for this. So let me make demo 1. Changes to exceptions. Okay. So let me write a process method and this is out. So I'm creating a process method. So in the process method, we are going to say system.out.println. Process line 1, and I'm going to hit integer k is equals 10 by 0. So I'm going to create an arithmetic exception here. And let's say I'm having some block here just to demonstrate this one. So you see here process line 1 is printed and then this got an error. So it says, it's happened in Java 13, line number Java 13, which is in the process method. And then it is called by main, which is in the line number 6, it's calling the process method. So it didn't execute these two lines when you get an exception. It's just skipping all these lines actually out here. Okay. So you can put a try catch block here and handle that exception, but it's not mandated. Like we are not asked to do that actually. It's not, compiler is not it's not complaining that you have to do a try catch or not actually. It doesn't say anything like that. Okay. Now let's do another example. So in this case, I'll see like, compiler is going to complain me that I have to handle it. Okay. Okay. So let's take, okay. We'll take a date class. Date d is equals new date of. So basically this is going to, the date class is present in Java. So which is going to be present in a package called java.util. So you see date class is available in java.sql and java.util. So we're going to use the date in java.util actually, not the SQL one. Now if you want to print the date, you can use sysout and you can print the date. Okay, so that's printing the date here. Next is what you can do is you can do scanner. You can accept a date from the user. So you can say scanner new scanner. Scanner is a class to use, get the input from any input source. So I'm going to get it from a keyboard, so I'm using system.in. System.in refers to the keyboard. So again, scanner class is coming from java.util package. So I'm just clicking on that. So you see here, these are utility package provided, utility classes provided by the Java. So now I'll ask the user to enter the date. Okay. And I'll try to accept that date using, so he cannot enter the date directly. I'm going to get that in a string format. He's going to, enter the date in a string. So he's going to say yes.next. So he's going to get the date now, and this is in a string format. I want to convert that into a date format actually. So he's going to just give a string, like say 05/21/2020, like this. He's going to give a string, and I want to convert that into a date object actually. So you can give any string, but I want to convert it into date. So I have a class for doing that. So the class name is simple date format. So I'm just creating an object of simple date format. Here I specify what is the format that the user is going to give me. So I'm going to get this in mmdd YYYY format. So this is M stands for you can access the simple date format in Google, and you will be getting like what are the various patterns or options you can give for getting the date actually. So it's available in java.text package. So if you see here, this stands for the month. It's in capital letter because here it is capital letter representing the month. If you put small case, it is representing the minutes actually. So that's the reason they made it capital. This is days, and this is year actually, in the 4-digit representation of year. You can also represent times like hour, minute, SS, like that actually. And the capital H means it means a different thing, and small h means a different thing, which is 0 to 24 and 0 to 12 timings actually. So so you can say I wanted to use the simple date format from java.text. So change this. Now you got how to define this date. What is the date you are expecting from the user, in which format of string you are expecting from user, you are defining it here. Now once you get the date in the string format, you wanted to parse that date using this object. So we have a method called stf.parse. Okay, whatever the date user is giving us, I'm going to parse that date with this standard actually. So he's giving some date in this format, so I'm just assigning that format to this one, so that I'm assuming that he's going to give in this format, and with that assumption I'm trying to convert that into a date object. So sdf.parse method is going to give you a date object, which is d1. So the moment I see, I put this sdf.parse, I'm getting an I'm getting an error here, right? So if you hover this error, it says, unhandled exception type parse exception, which means that if you are using this parse method, you need to handle this exception. You need to handle or throw. You are given two options. Either you handle it or you throw it. So when you say you are handling it, that means you are saying that I am aware of this exception, and here is the handler in case if the exception happened, here is the handler for it. That is the handling part. The throwing part is, I am aware of this exception, that this parse method can produce this exception, which is I am aware of, and I don't want to handle it. I want to throw it to the throw it back to the method whoever is calling me. In this case, main is called by JVM, so I want to give it back to the JVM. If this is done in the process method, then process method will be called by main method. So it's giving back to the main method. Okay, so the throws is the one which is saying like, so you have two options now. Either you can use a try catch, or you can use a throws to throw it back actually. So this is called as the checked exception. So parse exception which is produced here is a checked exception. That means compiler is not allowing you to proceed forward without handling it or throwing it actually. Why the compiler is doing that is because, think about it, how can you expect a user to give the date in this format? If he gives a like ABCD, what will happen? So he can give any date when you are asking for. He doesn't need to be mandatorily giving the date in this format actually, right? He can give it in any format. So if he gives ABCD, can you convert that ABCD into the date? You cannot. So what compiler is saying that is you have to be aware that when you are trying to parse this string into a date, you may get a parse exception. If you are getting that exception, I need a way to handle that. You have to provide me a handler for handling that. Either do that or at least acknowledge that I'm not going to handle it. Let my caller will handle it. But if the caller is also not handling it, he also need to either he needs to handle it or he needs to uh, acknowledge it actually. So let's do this. So here I'm saying, if I say I'm handling it, I'm just going to put a try catch around it. I'm just going to handle this parse exception method. But if I'm not, so the error is gone now. Either you have to handle it like this so that I don't have any problems. If you're not going to handle it, at least throw it back to the calling method, right? So that's where we are having a issue here. So I'm not going to handle it, but I'll be throwing it to the calling method. Let's move this all to a process method so that it's making more sense. I'm just moving this method to process method. I'm just going to, here, I don't want to handle it. I say, hey, I'm called by main and whoever is calling will handle this. So I don't want to handle this. So I'm going to say throws. So if I don't want to handle it, I can choose the second option, which is add throws declaration. So throws says that this method is capable of throwing a parse exception. It doesn't mean that it is going to throw a parse exception. If the user gives the date in a proper format, it will execute seamlessly, but it is capable of throwing the parse exception. So the method signature, I'm updating that it is throwing a parse exception. So when it is saying that this, what this process method will do is, here now this method is all set. There is no errors there. But when it is coming to this method, it's having an error. So now it is demanding the main method to handle this error or throw this error, because the process method is throwing this error to you. Now you have to handle it or you have to throw it. So now the main method can decide to handle it or it can throw it back to it can even say here, throws declaration, throws parse exception, or it can provide a try catch and handle it actually. So you can do either way to do these things. So if at all a method is going to throw like multiple exceptions, like it's throwing a parse exception, comma, IO exception, file not found exception, like multiple checked exception is throwing, you can put a comma and add more exceptions to it actually. That is one option. Or you can add a parent class, throws exception, which means it's a generic thing. If you just put throws exception, that means you can have any methods called here which is going to do a date parsing, do a file parsing, whatever it is, but it's not a good way to do it actually. You have to always be specific what exception this method can be able to throw, instead of throwing a generic exception or handling a generic exception is not a great idea actually. So now just putting this out, sorry, printing the date now. Okay, so I'm just going to execute this program. I'm saying enter the date, saying 10/10/2020. So it's good. So no errors. I gave it in the right format. I'm getting the proper results actually. No exceptions are happening here. Let's run this again. I'm going to give some text here instead of date. So I got an exception. You see that this exception happened, and while we tried to do the main method, which is like Java number line, which is a process method, it's happening in the 21, which is the here sdf.parse date. So when it is trying to parse the date, it happened the exception got. So when this exception has occurred, it's not going to execute the remaining lines of the program. It is going to throw it back to the calling method. So the calling method is also not having a try catch, so it is going to throw back to the calling method, but this is explicitly defined here. Whereas in case of runtime exception, this is not explicitly defined. You don't need to define it actually. If you define it, there is no problem, but you don't need to define that, or you don't need to try catch and handle it. So that's the difference between catch, checked exception and unchecked exceptions. So we handled we covered what is try, what is catch, and then also like we were also discussing about finally. Let's put it together in one class and see how things works. Okay, so let me open up one more class, which is demo 3. Okay, so in this I'm going to have integer array is equals 1 2 3 4, and I can say like this is out a of 4, string s equals abc. Sorry. And I want to do like integer k is equals s dot character at 6. So I want to say character at the 6th position here. Of course, this is going to produce error. This is out k. Okay. So now I wanted to put this in a try catch block. Of course, these two are going to produce an error. So I'm just going to put it in a try catch block, and I'm to handle this finally and all these things. Okay. So I can say like so here it is going to produce arrays index out of bound exception, array index out of bound exception. So because here there are only 4 elements and we are accessing the 5th element here. It starts with the 0 index, right? So 0 1 2 3 is there. A of 4 we are accessing, so it's going to produce array index out of bound exception here. So I'm just printing I'm just printing the message here. So you can say ae dot and then get message, which is going to print the exception message. It's not going to print the exception stack trace, it's just going to print the exception message. If you put ae dot print stack trace, it's going to print all the stack trace here. Okay. Now I can have one more catch block, which is going to be a generic exception, and it's going to say e dot get message. Okay, this object dot get message. Now I can have a finally block and just print finally executed. So this is kind of a catch-all. Any exception that is happening here will be caught here actually, because it's a broad classification here what we are putting. So you can have a catch-all exception block created, but the more and more specific exceptions you can have it along with the catch-all will be a real good style of programming. Let me run this. So we get 4. This 4 is nothing but the message what we got actually. So to be clear, I should put like a dot print stack trace, so that you see that there's an exception happening here. Otherwise it's not looking like an exception here. It's fine. You don't need to put system.printf if you're printing the stack trace. So just say ae.print stack trace, which is going to print it automatically. It's a void method. Okay, so Now run this. So you see here java.lang.index out of bound exception. You are trying to access the fourth element, fifth element here, which is not going to happen. And but still the finally is getting executed here. So even though you got an exception here, the finally block will be executed. So no matter whether you got an exception or not. So let me change this to 3. So which means now I'm able to access the proper element. Let's not 3, make it 2. So 2 means 0, 1 and 2. It's going to give 3 as a result. But it's going to fade it here. So let's see that. So 3 got printed, but you see string index out of range 6 is printed. So what happened here is it executed this statement, it got an exception here. So that's the reason it did not print K. So it did not execute the remaining lines of the program. Now it did not have any string index out of bound exception, but it is having an exception which is a broader classification. So it's not matching with this, but it matched with this because any exception is a subclass of this exception. So it is printing the message here and then finally is getting executed here. So that's the result you are seeing in this string index out of range 6 is the message what we got actually. So no matter what, if you are, let's say here we are giving a proper string like 0, so it's going to print A here. Now everything is corrected in the program. Now there is no catch exception will be invoked, but still you will get the finally block getting executed. So we covered try, catch, finally, and then throws. The last one is the throw class actually. I think we have a bank account program created in some place. Let me copy that. Where did we did that? Think in a, yeah, here you go. So let me copy these two things again to this. Okay, so I have a bank account class which is going to have account number, address, balance, and then we have a deposit method, we have a withdraw method, all these things, and the test method for testing this class basically. Now let's add one exception here, user defined exception here. So I'm just going to say class invalid amount exception. So I'm just creating my own exception, invalid amount exception, and then say finish. So I want to extend it from a runtime exception so that I don't want the user to handle this or throw it those type of situation. Extending from runtime exception. Okay, so I can leave it as it is, but I just want to have one more constructor here which takes the double argument. So that is not there in runtime exception. So I'm just including that constructor here, public, and then it will take a double amount. I hope I have created double only here. No, it's int. Okay, so let me take it as int here. The amount is integer there. Okay. So what I'm going to do is I'm going to call the superclass constructor and then say, because they accept only strings there, so I would say invalid amount and then pass this amount. So I'm just creating a constructor which is taking an integer argument and passing a string argument to the parent constructor. Okay, so I created my own exception which is invalid amount exception. Now I'm going to use this exception in my program. So you go to a bank account and say like, if the user is depositing some amount, I would first want to check if amount is greater than or equal to greater than 0 basically. If he's not giving, if he's giving less than 0 or if he's giving less than or equal to 0, then I have to throw an exception. So if the amount is less than or equal to 0, I'm going to say throw. Here is the one we use throw keyword, throw new invalid amount exception, and I'm going to pass that amount, what amount is invalid actually. So when I throw this exception, see, I was not asked to handle it or throw it here. When I throw this exception, this exception does not mandate me to handle it or throw it actually. So because it is extending from the runtime exception. If at all I have not done this, if I have extended from exceptions, okay, now what will happen is exception or any of its subclasses. Now what happens is here you are throwing an exception. So it says, you are throwing, you have to either add throws declaration here. So this should say you have to add it here because this method is throwing an exception. So you have to add it here because that's the checked exception. And whoever is using this, right? Say, if I save this, this guy is using this method. This method, if main is using this method, he has to handle it or throw it here, right? Just like our parse method actually. When we did the parse, parse is defined by the simple date format class, and when we use the parse method, it said you have to handle it or throw it because the parse method was having the let me show you that the parse method in the simple date format. If you see here, they were having a throws parse exception, so it is capable of throwing a parse exception. It was throwing a parse exception here, so that is the reason since it was throwing a parse exception here. When we called this method, we have to handle this or throw it because this is a parse exception is extending from the exception class, not the runtime exception class. So that is the reason we have to handle that. But in our scenario, if at all we didn't do this, like we extended from not an exception class but a runtime exception class, we don't need to worry about this. No one, I mean, they can directly call this method without worrying about to handle it handling it actually. So let's say this guy is depositing minus $1,000 here. Okay, what will happen here is when he's creating a bank account and depositing minus $1,000, since we have a code to handle it, it's going to throw an it's going to stop the execution. It's not going to execute anything. It's going to stop here and throw an exception to the calling program. Say this exception is not a regular exception. This is something like exception. This exception is going to be a custom exception, which we created. See here, invalid amount minus 1,000. So like this in your project, you can create multiple custom exceptions, and you can throw that exceptions when the clients are calling them, and they can handle it. If for such exceptions actually. I think we covered all these things. So the one new, I mean, in Java 7, all these syntax are all based on Java till Java 5 syntax. What we are covering. In Java 7, there is a better way to handle this. You can put in the here, if at all the handler block is same. Let's say we are going to just print the exception only. The handler block is same. You can put like this. If it is a array index out of bound exception, or if it is a string index out of bound exception, you can put art symbol and you can add, and then you can say like how to handle that, because if the handler is same for this, you can define like this if you are using Java 7 or more. Actually, this is a simpler syntax. And also in the try block itself, they are defining any resources that you're opening. Like for example, if you're opening a file resource or anything, if you open it here, you don't need to specify the finally block here. So it will automatically close the resources. If this is if you are going to use the try block with this actually, and you define all your opening resources over here. So you can define scanner, you're opening as s equals new scanner of a file, say file.xml, whatever it is, file.txt. So these things will be automatically, this the object will be closed. S.close will be automatically happening. So you don't need to care about defining a finally block. Anything that you define here within this will be automatically closed and freed up by the memory actually. So this is a new syntax from Java 7. One is catch can include multiple catches, and try can put the opening any resources that you're opening can be put inside this, which handles automatically the closing of resources. That's with respect to Java 7 syntax.